So hello everyone and welcome back to our YouTube channel. Today we are going to start a topic called as Fourier transformation. So to begin with, let us consider a function, say f of t, defined in a interval minus infinity to plus infinity. Then Fourier transform of f of t is defined as capital F of t equal to 1 upon under root of 2 pi minus infinity to plus infinity e to the power ist f of t dt. Suppose let this be equation number 1. Now this function, that is Fourier of f of t, this can be written as capital F of s equal to 1 upon under root of 2 pi minus infinity to plus infinity e power st f of t dt. Let this be now equation number 2. Now from these two equations we can clearly see that if the function is defined with respect to t, then on applying the Fourier transformation, this function is changed into function of s. So which implies that a time domain on application of a Fourier transform is changed into frequency domain, which is one of the most prominent application of Fourier transformation used to analyze signals for different frequencies. Not only this, but one can convert a function in, say, space coordinate to a function in, suppose, say, momentum space or k space, and also in momentum space. On recalling, in quantum mechanics, a wave function defined in, say, position space on application of Fourier transform, it is converted into momentum space. So in order to convert a position space wave function, we do the Fourier transformation and it is converted into momentum space. So generalizing this, we can write down that Fourier transformation for any given function f of x, this can be written as 1 upon under root of 2 pi minus infinity to plus infinity e to the power isx f of x dx. Not only this, but the inverse Fourier transformation of this given, suppose, say, equation number 3 can be written as f of x equal to 1 upon under root of 2 pi minus infinity to plus infinity e to the power minus isx f of s into ds. And suppose, say, let this be equation number 4. So from all these data, one can see that the function in one domain is converted into another domain. It might be such that the behavior of the function in one domain is different compared to the behavior in the second domain, and that can be clearly seen with, suppose say, we will consider a particular example, and from that example it will be clear that how the function's behavior changes. Now suppose, let us note down a question. At the given wave function or given function, suppose say f of x is equal to 1 0. Suppose the function value is 1 for the range mod of x less than a, and it is 0 for mod of x greater than a. So on starting the solution, let us define this function as, let f of x equal to 1. Now this condition mod of x less than a is nothing but minus a less than x and less than a, and it will be 0 for all other values. So if we plot this function can be plotted like, suppose, let us consider this function, the function in the range of say minus a to plus a. It is having value 1 which is constant, and the function is having 0 value otherwise. The function will look like this. Now suppose if you want to do the Fourier transformation of this function, so we have that f of s will be equal to 1 upon under root of 2 pi minus infinity to plus infinity e to the power isx, now f of x into dx. Now we have a function which is defined for this interval like minus a to plus a and otherwise. So the function can be written as 1 upon under root of 2 pi. Now the limits I can write down directly like minus a to plus a because it is having value 0 otherwise. So limits will be minus a to plus a e to the power isx f of x dx. Now for the limits minus a to plus a, the function has value only 1. So f of s can be written as 1 upon under root of 2 pi minus a to plus a e to the power isx, f of x value is 1 into dx. So f of s will be equal to 1 upon under root of 2 pi minus a to plus a e to the power isx into dx, which is equal to 1 upon under root of 2 pi. The integration of e to the power isx is e to the power isx divided by iota times s, and the limits are minus a to plus a. So this function f of s will be equal to 1 upon under root of 2 pi into 1 upon is. If I put the limits, this will look like e to the power isa minus e to the power minus isa. On multiplying and dividing by 2, this will be f of s equal to 1 upon under root of 2 pi into 1 upon iota s into 2 divided by 2 e to the power isa minus e to the power minus isa, which is equivalent to 2 upon under root of 2 pi into 1 upon s into e to the power sa minus e to the power minus isa divided by 2i, and the quantity written is bracket is nothing but sine of sa. So on solving this again we will get f of s equal to under root of 2 by pi sine of as divided by s. So the Fourier transformation of the function, which was looking like this from minus a to plus a, it was having a value 1. Now you can see clearly the Fourier transformation of this function is looking like in rectangular shape is converted into a sinusoidal function. So the Fourier transformation of this will look like a sinusoidal wave. So clearly from this it is clear that whenever we do the Fourier transformation of a given function, its behavior can change. So if we try to analyze this for another function, let us say if we consider second function where we take f of x equal to e to the power minus ax square, which is like a Gaussian function where a is greater than 0. And if we try to solve this function, let us try to solve this function again with respect to Fourier transform. We have f of s equal to 1 upon under root of 2 pi minus infinity to plus infinity to the power isx into f of x dx. Now this f of s will be equal to 1 upon under root of 2 pi minus infinity to plus infinity to the power isx into e to the power minus a x square into dx, which can be written as f of s equal to 1 upon under root of 2 pi minus infinity to plus infinity e to the power minus ax square plus I times sx into dx. Now this can also be written as f of s equal to 1 upon under root of 2 pi minus infinity to plus infinity to the power minus sign if we take common, so this will be ax square minus iota sx into dx. Now suppose let this be equation number 1, and we have a standard integral which states that if the integration is from minus infinity to plus infinity e to the power minus ax square plus bx dx, its value will be under root of pi by a e to the power b square upon 4a. Now if you compare both of these equations, you will clearly get that the value of a is only a and the value of b can be taken as minus of is. And if you put the values, you will get f of s equal to 1 upon under root of 2 pi into pi by a into e to the power minus s square divided by 4a, which is nothing but f of s equal to e to the power minus s square by 4a divided by under root of 2a. So from this it is clear that the Gaussian function remains the Gaussian. That is, clearly if you take a Gaussian function and if you do the Fourier transformation, it remains as a Gaussian function. So that is it for this lecture. Keep supporting. Do like, share and subscribe.